So in the last 3 presentations, we learned what different applications in the maritime industry are possible and can be covered with LiDAR scanners. Now and finally, for the block people, object and hazard detection, we are proud to present a solution to avoid fire risks aboard ferries. So fire aboard is one of the most critical things which can happen, as ships are always far away from land and help is determined very slowly.
Yeah, that's true. And as Ramona said, a ship is always on their own, and fire workers are far away. We have an application, and SICK developed this system primarily to prevent fires in tunnels caused by trucks and cars. And we have that system already since years installed in several tunnels. And this vehicle hotspot detection system is developed further to fit also to maritime application. And in the combination of a LiDAR scanner and infrared camera, we are able to detect potential risk, fire risk on cars, loads and trucks before entering a ferry. That sounds complex. It is, but we are happy to have now Christoph Gilgen from SICK in Switzerland here, and he will explain us in detail about that system and how it works. Hello, Christoph. Could you explain what you're going to present in the next 15 minutes?
Hello, everybody, and thank you for this introduction. My name is Christoph Gilgen, and I'm gonna explain you the vehicle hotspot detector developed by SICK AG. I'm working in a role as a product manager, and I will lead you the next 15 minutes through this presentation and will give you also a short insight to our user interface. Does such a picture also shock you? Me, it does. But unfortunately, this is just one of the latest example happened in April this year in Asia. According to the local media, the smoke was seen coming from one of the trucks loaded on the vehicle deck. This and other such sad examples is one of the reasons why we further developed our vehicle hotspot detector, which is already in use in front of tunnels for port applications. The goal, as in tunnels, is also here in the ports to prevent fires before they already happen. So finally, the system will improve your safety in ports and also on ferries. Additionally, it also improves the loading process at the ferry terminal. But now I will show you in detail how this works. So one of the core components are the 2D LiDAR sensors from SICK, which are mounted on this gantry to profile each vehicle entering the port. Additionally, we have mounted an infrared camera on each side of the gantry to measure the temperature of the vehicle passing our gantry. And for sure, we can add additional useful modules. So, for example, such an overview camera, overheight detection, license plate recognition, dangerous goods plate recognition, and so on. So these are optional modules additional to the 2D LiDAR sensors and the infrared camera, which are the heart of the system. But let's go a little bit more into the details. So for the vehicle profiling, we use these 2D LiDAR sensors, LMS, which you may already know. Thanks to the movement of the vehicle under our gantry, we can create a 3D point cloud. This is what you can see here on the left-hand side. 2 examples what we create with these 2D LiDAR sensors. With this 3D point cloud, we can also do a dimension measurement. That means we can, to the operator, also provide the width, the length, and the height information of each vehicle, which can be interesting for the loading process. And this point cloud is also used for the classification of the vehicle. So we let the operator know if it's a truck, a bus, semi-trailer, or whatever. For the vehicle surface temperature measurement, we use IR cameras. They produce such a 2D thermal image in a temperature range from 0 up to 500 degrees Celsius. What is the software doing afterwards, step by step? So first, we do this classification. So we know exactly, for example, it's a semi-trailer. This will also be used later on for the segmentation. After we have the 2D and the 3D point cloud and the 2D thermal image, we combine this information and we get a 3D thermal image. This is the base for the investigation of the vehicle afterwards. Then the segmentation process starts. So as we know, it's a semi-trailer, for example. We know in which zone the engine, the wheel, the loading zone and the passenger zone is. So for example, for trucks, we allow to have higher temperature in the engine zone, which is somewhere here under the cabin, between the cabin and the trailer. And in a bus, we know in this segment here on the back is typically the engine, when we allow here a higher temperature than, for example, for the wheel segment. So we can build a matrix internally in the software, which is based on the different classes and based on the different segments. That means we have individually adjustable alarm thresholds for each segment. So for example, for a bus, we allow to have wheel temperatures up to 70 degrees Celsius, whereas for a truck, we have maximum temperature in the loading zone of 60 degrees Celsius. If one of the temperature here in the matrix is exceeded, the system will automatically raise an alarm. But why should a hotspot detector be installed in a port? For sure, it's an easy way to identify potential fire risks. So we can detect individual vehicle zone, localize it in the 3D user interface, which will I show later on, and it's quite easy to adjust different alarms per vehicle, per segment. It also guarantees you a smooth flow of traffic during the loading, so it means it doesn't affect the flow of the traffic. So we just need two gantries, but the traffic can enter the ports quite normally without being stopped or something else. And we can also do retrofitting, means we install our system very often also on existing infrastructure. So to sum up, the system is improving the safety in your port or in the ferry and allows a smooth loading process. But now I'm switching to the user interface, just to give you an impression what the user can expect. So here, for example, we have one of the trucks measured on our test site in Sweden at the Lashfire project. We see on both vehicle sides nothing suspicious. So here on the left, we see the different vehicles past our system. We have date, time, we have the location, speed, width, length, and height of each vehicle, the category, and here we have these individual vehicle parts. But here, nothing suspicious. So I have here the 3D point cloud with the overlay of the temperature, and here we have the 2D thermal image. If we check another vehicle, we see there is already something suspicious. For example, here we have the exhaust, which has a little bit higher temperature than the rest of the vehicle, but we can also see this belongs to the engine area, so nothing special. If this would be, for example, in the loading area, which I marked now, this would already raise an alarm because the temperature is higher than it's allowed in the loading area, but not higher than it's allowed to be in the engine area. Here we have an alarm from one of the trucks past our system. These wheels were warmer than 70 degrees, and this raised automatically an alarm. Sure, we can also mark here some areas and then directly measure the temperature. So they were above 70 degrees. If the operator is now interested to see some more details, we can also check the pictures of this area. But here nothing is obvious. So I estimate the operator stopped this truck and checked what the issue is, and maybe let him cool down a little bit before loading on a ferry, or let him repair the mechanical defect. Very often we can also detect mechanical issues on a truck. For example, here we see very clearly this truck has no issue at all, except this wheel on the fourth axle, which had a temperature of 250 degrees Celsius. That means probably there was an issue with the braking system, a pressure loss or whatever. So I think we all agree that nobody of us would like to have such an overheated truck loaded on a ferry. Good. This was it from my side. And now I'm handing over to the interview with Markus Voss.
Thank you, Christoph, for handing over the stage to us. I have in the interview now Chris Ladach from the Center for Maritime Technologies in Hamburg, as well Martin Karlsson, a project manager fire safety at Stena Teknik Sweden. First of all, I want to give the words to Grit for introduction of herself, and please, Grit, continue with your intro.
Hello, my name is Grit Ladach, and I'm working for the Center of Maritime Technologies in Hamburg, Germany. CMT is a recognized research center and coordinating body that conducts its own technical research in strategic maritime domains.
Thank you, Grit, for your intro. Martin, please, can you introduce yourself and give some words to you?
Yes, certainly. I am Martin Karlsson, and I am a naval architect as a background, working with Stena Teknik, mainly with fire safety in various projects and internal work. And I'm the Stena project manager in Lashfire, and just shortly, Stena Line is operating a Northern European network of Ro-Ro and Ro-Pax vessels. So that's why we're interested in this.
Thank you, Martin, for the intro and also introduction of Stena Line. My first question goes to Grit, related to the Lashfire project. And my question is, Grit, what is the main task of the R&D project Lashfire, and what does the project include?
Okay, so in a nutshell, in Lashfire, we are developing a very nice technical basis for the revision of IMO regulations to greatly enhance fire prevention, but also ensure independent management of fires for Ro-Ro ships. What does that mean? We are in total investigating in 20 solutions to improve fire safety on board Ro-Ro ships. So covering the whole fire chain, starting with prevention and detection to early response, to efficient fire fighting and containment. And so we are also covering operations and design aspects, and all our solutions we are developing will be tested and evaluated mainly on board, but also in lab tests. Throughout the whole process, there's a Maritime Operators Advisory Group, a group we established in the very beginning with 12 members, 9 of which are also operators, and we are receiving valuable input and feedback on our proposed solutions for the project by the end users. Based on our findings and with the support of a second advisory group, namely the Maritime Authorities Advisory Group, comprising 12 members as well, 9 flag states are involved. Also, EMSA as European Maritime Safety Agency, or ERINA as Classification Society. And with their help, we are drafting 15 proposals in total, and which will be submitted towards IMO. I think this is a very, very special feature of this project.
Thank you, Grit. So this is a huge involvement, and 27 states all over Europe are involved, and project members. And this gives a really deep impact on future-orientated safety aspects on Ro-Ro ferries, car carriers, and Ro-Pax ferries.
Absolutely.
Martin, can I have a question to you? What is the motivation to invest in prevention on the fleet of Stena Line in fire protection?
Well, the first one obviously is this safety aspect, to secure the passengers, crew, and the ships, and this also fits very well to the company general safety spirit, and we even had an active decision in top management some years ago that we should not have any severe fire incidents in our company, and since then we act in this direction. Also, we see now new energy carriers coming, such as electric cars, etc. So we need to be ready with any new, let's say, safety measures needed that day. Next area is harsh economy, cost avoidance, direct and indirect. If something bad happens, it's always cost associated, and we rather spend resources proactively than afterwards to clean up. That is better in many aspects. The third and last is society. I mean, Stena has an outspoken ambition to support society, the whole industry, shipping industry, and research. So this is a way to do that, and we would all suffer if something happens anywhere in the shipping industry. So let's do it together.
Thank you. That's a really good background to invest in fire prevention and participate on the Lash fire from Stena Line. In the project, the vehicle hotspot detection system is installed in a terminal in Gothenburg. And what experience and expectations do you have on the vehicle hotspot detection system?
Yeah, the system is in place since a couple of months, and the commissioning is ongoing. Heat profiles are detected for each vehicle passing into the terminal already now. After the summer now, we will conduct machine learning and to teach the system what is right and wrong, to give, let's say, an alarm when we detect anomalies, so we can act on them. We are also evaluating in the project if an alternative installation could be better on board the ship at the stern ramp. There are different pros and cons. I also would like to mention a positive side effect on the commercial side on this. If we make the scanning of the vessels in the terminal, we get the validation of the booking of the identity of the unit and the shape of the vehicle. And if we have a mismatch, we have a possibility to adjust the stowage instead of realizing such a mismatch at time of loading. Then we will cause some waiting time to the situation. So in this aspect, it stabilizes our turnaround operations. Yeah.
Really good.
Yeah.
Thank you, Martin, for these practical aspects and new development within the maritime industry of the vehicle hotspot detection system for early detection and prevent fire hazard on board. The project will go on another 2 years, and the outcome will be published in the UE portal and in some publications to the maritime industry and also to the flag states and notified bodies, and at least it will also influence the regulations in the IMO. I will say thank you to you both for the interview, and good luck with the ongoing project, and take care of you. Thank you.
Thank you very much, Christoph, and also thank you very much, Markus, for this interesting insights and showing us also how this complex situation can be solved very easily. So we have some questions in the chat for you, Christoph. Let me ask you, can this system be installed into engine rooms and combined with machine learning to detect potential developments of hotspots?
I would say not exactly this system. This is a profiling system, means we need some moving objects going through our gantry, but we can consider about further development of such kind of system to also use it in the engine room.
Sounds interesting. I guess they are looking forward to that as well. What is the detection rate of it?
This is highly depending on the application and on the location of the system, and for sure also on the alarm thresholds. That means the higher the alarms, the higher the thresholds, the lower the alarm rates, and vice versa. But if you detect just one single vehicle, it was already worth the investment. So I would go a little bit lower with the limits just to have more vehicles detected.
That's very true. I mean, such a fire is never a good idea, so better pretend it instead of repairing it at the end. Maybe a last question. How many overheated trucks on deck are detected per year? Can you answer that?
Also, this is depending on the number of trucks measured. I would say there is an alarm a few alarms per week, a few alarms per month, depending on how many trucks you have, and also here where you set the limits. If you have a strategy to have lower limits, you have more alarms, which helps you to improve the safety finally.